Okay, today we're going to talk about systems of equations. Systems of equations are two or more equations that have the same solution. So in other words, we're looking for where they intersect at. Now, on the first one, the example here, there are two equations in the system, and on the second one there are three equations in the system. We're going to be doing both type as we go along through this lesson. Now to start off, we're just going to see if certain things are solutions to the system or not. Since we don't know how to solve the system by hand yet, what we're going to do is we're going to plug in 6 for x and negative 1 for y. So 2 times 6 plus 3 times negative 1, 12 minus 3 is 9. Check, it works for that one. Don't get too excited. It has to work for the other equation too for it to be a solution to the system. So now I'm going to take the 6 and put it into these. So negative 5 times 6 minus 3 times negative 1, negative 30 plus 3, negative 27. No, so this is not a solution to the system. It has to work for both of them to be a solution to the system. So let's try the next one. 2 times negative 3 plus 3 times 5 equals 9. Negative 6 plus 15 equals 9. 9 equals 9. First one works. Let's try the second one. Negative 5 times negative 3 minus 3 times 5 is 0. 15 minus 15 is 0. Works. Therefore, this is a solution. Now, just because you find one solution doesn't mean that there's not another. Remember, there are three things that can happen, and if we look down here, one, we can have intersecting lines where there's one solution. This is called a consistent system or conditional. And they're intersecting, they cross at one point, and it's called a consistent. You'll find one answer. But you can have a parallel lines, meaning there are two lines that are parallel, they will never touch. So far there's no solution, and it's an inconsistent system. So maybe none of them will work. So don't just assume that if you've gotten through the first three, the last one has to work. None of them have to work. Coincide means that the lines lie on top of each other, so it's the same line. If it's the same line, they're dependent. It's called the identity system. And on the identity system, it's all real numbers. So all of them could work. So don't just assume because one of them works that that's the only one that works. And don't assume that one has to work because none of them have to work if they're parallel. Okay, let's see what we got on the next one here. 2 times 2 plus 3 times 1 equals 7. 4 plus 3 equals 7. Check for that one. 3 times 2 plus 1 equals negative 7. 7 equals negative 7. X for that one. 2 times negative 4 plus 3 times 5 equals 7. Negative 8 plus 15 equals 7. Check for that one. 3 times negative 4 plus 5 equals negative 7. Negative 12 plus 5 equals negative 7. Negative 7 equals negative 7. Check for that one. So here's a solution. Two times negative 2 plus 3 times negative 1 is 7. Negative 4 plus negative 3 is 7. Negative 7 is 7. X for that one, so no for that one. So B is the only solution. But remember, you can have one solution, no solutions, or many solutions, depending upon if they cross once, intersecting, and they're conditional, or they're consistent, or if they're parallel and they're inconsistent, or they coincide and they are the identity, where the identity makes it so that it's all real numbers. Okay, the way we are going to be solving systems are the following four options. We're either going to graph them. That means all the equations are put in y equals mx plus b form, and you graph and you look for their intersection point. Or two, we're going to use substitution, where one equation is solved for a variable, and we're going to substitute that value in for the variable into the same variable in this other equation. Then when we get our answer, we'll plug it back into the first equation and find the answer to the other variable. Or we're going to do elimination. We're going to put equations into standard form, ax plus by equals c, and then we're going to eliminate one of the variables, and we may need to multiply one or both the equations by a number to get the variable to drop out. And we're going to add the equations together, solve for the variable that's left, plug it back into one of the two equations, and get the other variable. Or we're going to do equal value. This can be used instead of graphing. It's when they're both equal to y, and then you set them equal to each other. Find out what x is and plug x back into the value. Equal value is very useful instead of graphing when you don't have graph paper or the lines do not cross at a corner. Okay, so we're going to start with elimination. So with elimination, you can see that these are in standard form, ax plus by equals c, ax plus by equals c. The x's are in line, the y's are in line, the equals are in line, the constants are in line. That's very important. You also should notice that if I add together right now the x's, they will not drop out. If I add the y's together, they will not drop out. I need either the x or y to drop out. So I've decided to multiply the first equation by -1. When I do that, I get -x, -y, +1. By doing that, I have not changed the value of the equation. Because I've done it to everything, the value is still the same. It's just in a different form. What that allows me to do now is to take -x plus -2x and get -3x when I add them together. The y's drop out, and 1 and -7 is -6. I can divide by -3 and find out x is 2. I take 2 and I can plug it back into either one of these equations. It makes no difference which equation I plug it into. I'm plugging it into this first one. So I took out x and put in 2. 2 plus y equals -1. Move my 2. Y is equal to -3. Therefore, my answer is 2, -3. That's an elimination. Must be in standard form. X's must be in line. Y's must be in line. Equals must be in line. Constants must be in line. Once you find your answer and the one variable drops out and you find the answer, plug it back into one of the two equations to find the second answer. In the next example, we're doing substitution. In substitution, one of the variables are already solved for. So y is equal to -3x minus 9. That means everywhere I see y in the second equation, I can put -3x minus 9. So I had -2x, so I wrote -2x down, plus 3. Instead of y, I put -3x minus 9 equals 17. Distribute -2x minus 9x minus 27 equals 17. -2x and -9x is -11x. If I take my -27 and move it over, it becomes +44. Divide by -11. X is -4. So then I take my -4 and plug it back into either equation, but truly, the equation that you did the substitution for is always the easiest one to plug back into. So -3 times -4 is 12, minus 9 is 3. So my x was -4, and my y is 3. So it crosses at -4, 3. So if I graph them, they cross at -4, 3. On the first two, the first equation here, if I would have graphed it, it would have crossed at 2, -3. That's what we're doing. We're finding out where it would cross at. Okay, graphing and equal value. I'm going to do graphing and equal value at the same time because if you can't do one, you can do the other. Graphing, start at +5. 1, 2, 3, 4, 5. Drop 4. 1, 2, 3, 4, and go right 1. I'm going to do it one more time so I can maybe keep my lines straight. Then on the next one, it says go up to +3. Drop 2 and go over 1. Drop 2 and go over 1. Now, if you're not sure where it crosses at, do equal value. Take the two and set them equal to each other. If they're both equal to y, then they're both equal to each other. So -2x. So it's a drop 3 and over 1, so it crosses there. That's probably my problem. -2x is equal to -2 divided by -2. X is 1. Plug 1 back in. Negative 2 times 1 plus 3. Negative 2 plus 3 is 1. So it crosses at 1, 1. And if I did my line right, they would cross there too. So let me do it again. 1, 2, 3, 4, 5. Down 1, 2, 3, 4, and over 1. 3. Down 1, 2, 3, and over 1. So I'm supposed to be getting across at 1, 1. Now you can see graphing's not easy if you don't have graph paper, don't have a ruler, okay, or it doesn't cross at a corner. It did cross at a corner. I did have graph paper, but it didn't have a ruler. Therefore, it didn't work out great. But you can always go to equal value if it doesn't. Okay, so on the next ones, we're going to choose the best method first, and then we're going to solve it. So our choices are elimination, substitution, graphing, or equal value. Okay, the first one is set up into x's are in line, y's are in line, equals are in line, constants are in line. So in other words, it's set up in standard form. This is definitely an elimination. The next one is solved for y on the top. Substitution would be the best. In the next one, it's y equals, so that would be graphing or equal value. On the next one, the x's are in line, the y's are in line, the equals are in line, the numbers are in line. It's in standard form, so elimination. On the next one, x's are in line, y's are in line, equals are in line, numbers are in line, standard standard form, so elimination. Solving, it's already solved for y, so a substitution. Okay, let's see what we get. Let's solve them. Okay, on the first one, if I add the x's together, they do not drop out, but the y's do drop out. Well, that's not very good. The y's do drop out, so I'm going to drop my y's out. I get negative 6x equals negative 3. Divide by negative 6. X is 1/2. Take my 1/2 and plug it back into whichever one I want. I'm going to plug it into the first one. And it makes no difference. Whichever one you like better is fine. And I end up with a fraction. Well, guess what? Fractions are numbers. So that's not a problem. 1/2, 7/3. And if you want to see if they work or not, plug 1/2 in for x and 7/3 in for 3 in both equations and make sure they work. I'm going to skip down here and do another elimination, show you how they work. If I add my x's together, add my y's together, nothing drops out. So if I multiply the top by 2, this will become 6x plus 2y equals 2. I'll scratch that out because I'm not using that right now. My x's drop out, my y's drop out, my numbers drop out, so I get 0 equals 0. When does 0 equal 0? Always. So the answer is going to be all real numbers, meaning that these are coinciding lines and it's the identity property. Meaning it's the same line, so everything works. They're laying on top of each other. The next elimination, I'm going to multiply by 2 on the top. I get 6x plus 4y equals 4. X's drop out, y's drop out, I get 12. 0 equals 12. Well, when does 0 equal 12? Well, 0 never equals 12. Therefore, there is no solution, and that is a symbol for no solution, meaning that they never cross. If they never cross, they're parallel lines. So we can tell if it's a conditional answer, or consistent answer, inconsistent, parallel, or if it's an identity. All real numbers. Now let's look at our substitutions. I'm going to take this and plug it in here. So I get 5x plus 3 times negative 3x minus 5 equals 1. 5x plus negative 9x minus 15 equals 1. Negative 4x, move my 15 over, equals 16. Divide by negative 4. X is negative 4. I'm going to take my negative 4 and plug it back in here. Now I can do it into either equations, but that one's always the easiest on a substitution. So negative 3 times negative 4 minus 5, 12 minus 5. 12 minus 5 is 7, so y is 7. So it'll cross at negative 4, 7. Is it consistent? It's consistent, conditional, with the condition that it crosses at negative 4, 7. Okay, let's do the other substitution. This one goes in here. So I have 6x minus 2 times 3x plus 2 equals 1. 6x minus 6x minus 4 equals 1. The x's drop out. Negative 4 equals 1. Well, when does negative 4 equal 1? Negative 4 never equals 1. So there's no solution because these are parallel lines and they're inconsistent. If I spell parallel right. Okay, and graphing an equal value. I would probably not graph this because of the fractions starting out at 1.5. I'd be worried that it's not going to cross at a line. So I'd probably do an equal value on it. 3/2 x plus 3/2 is equal to 4/3 x plus 2. I'm going to lose my fraction with a 6. So multiply by 3, multiply by 3, multiply by 2, multiply by 6. 9x plus 9 equals 8x plus 12. Subtract my 8x. Subtract my 9. X is equal to 3. Then I'm going to take my 3 and plug it back into whichever one I want to plug it into. It looks like it's easier to plug in here. So 4/3 times 3 plus 2 drops 4 plus 2. 6, so y is 6. So this crosses at 3, 6. Conditional, consistent, crosses at 3, 6. So if I graphed it, it would cross at 3, 6 as well. Okay, so now we're going to do some problem solving with systems. Ariel is thinking of two numbers. She tells you that the sum of one number and 3 times the other number is negative 12. The difference of twice the first number and the second number is 32. Now always read the equation first, and then I go sentence by sentence. Ariel is thinking of two numbers. I'm going to call my numbers x and y. X will be my first number, y will be my second number. She tells you that the sum means I'm adding, of one number, x, and 3 times the second number is negative 12. The difference, that means subtraction, of twice the first number and the second number is 32. So I've just set up two equations, and they are set up in standard form, so they're set up in an elimination. I think I'm going to multiply this one by 3 and get 6x minus 3y equals 96. The y's will drop out, and I'll get 7x equals 84. Divide by 7. X is 12. Now, I'm going to plug it back in and find out what y is. I'm probably going to go right to the first one. So 12 plus 3y equals negative 12. Move the 12. 3y equals negative 24. Divide by 3. Y is negative 8. So my numbers are 12 and negative 8. And like I said, if I want to double check and make sure they work, I can put them back into both equations and make sure that they work. Four hot dogs and 3 sodas cost $22.25. 5 hot dogs and 4 sodas cost $28.50. How much is a hot dog and how much is a soda? Well, sentence by sentence. I have hot dogs, which I'm going to call H, and I have sodas, I'm going to call S. Now, if you don't like your S's, because you get them mixed up with your 5s, call it D or whatever you want to call it. Okay, so 4 hot dogs plus 3 sodas equal $22.25. 5 hot dogs and 4 sodas equal $28.50. Now, if I wanted to know what sodas cost, I'd get rid of hot dogs. If I wanted to know what hot dogs cost, I'd get rid of sodas. But since I want to know what both of them cost, it makes no difference what I get rid of. So I'm going to multiply the top one by -4 and the bottom one by 3. The reason for that is then my sodas will become -12 and +12, and they will drop out. So I get -16H minus 12S, 2225 times -4 is -89. Then I get 15H plus 12S equals 2850 times 3 is 8550. Drops out -1H equals 89, -89, and 8550 minus 8550, and it's going to be negative, so -3.5 divided by -1. So my hot dog must be $3.50, and make sure you make it into money. $3.5 is not normally how we write things. Now I'm going to take the $3.50 and I'm going to plug it back into one of the two equations. I'm going to plug it into this one. 4 times 350 plus 3s equals 2225. 4 times 350 is $14 equals plus 3s equals 2225. Subtract your $14. 3s equals $8.25. Divide by 3. 825 divided by 3 is $2.75. So it's $2.75 for a soda, and it's $3.50 for a hot dog. And make sure you answered your question. How much is a hot dog and how much is a soda? And I answered both of those. The dog's fence perimeter is 180 feet. The width is 25 feet plus the length. What is the dimensions of the dog yard? Okay, let's start with the first sentence. The dog's fence perimeter is 180 feet. So perimeter is equal to 2L plus 2W. And the perimeter from this says it's 180. The width equals the 25 plus the length. 25 plus the length. So this is a substitution. I'm going to take 25 plus L and plug it in every time I see W. So 180 equals 2L plus 2 times 25 plus L. 180 equals 2L plus 50 plus 2L. 180 equals 4L plus 50. Move my 50 over. 130 equals 4L. Divide by 4. L is 32.5, and since our perimeter is in feet, this will be in feet. So that is our length. The question is, what are the dimensions? So I need the width. The width is 32.5 plus 25, because that came from here. That gives me 57.5 feet for the width. So 32.5 feet by 57.5 feet. Length, width. Vertical angles are x plus y and 3x minus 2y minus 5. Supplemental angles are x plus 3y and x plus y. What is x and what is y? Here's something for you to remember. Vertical angles are congruent, meaning that they're the same, which means that I have to take the x plus y and set it equal to the 3x minus 2y minus 5 for my vertical angles. Supplemental angles have a sum of 180, which means if I add the two of them together, I will get 180. I now have to determine what method I want to use. And I definitely don't want to graph. And I don't want to do substitution because there's too many y's and too many x's. So I'm going to go to elimination. So I'm going to take my 3x and move it over here and get negative 3x. I'm going to take my negative 2y, move it over here and get positive 2y. So now I have negative 2x plus 3y equals negative 5. I'm going to gather terms here and get 2x plus 4y equals 180. Now I have two equations that are both in standard form. And in fact, when I add my x's together, they're going to drop out right away. So I get 7y equals 175. Divide by 7. Y is 25 degrees. Plug it back in, and I can plug it in here, I can plug it in here, I can plug it in here, I can plug it in here. So make your choice. I'm going to plug mine in here. So negative 2x plus 3 times 25 equals negative 5. Negative 2x plus 75 equals negative 5. Move my 75. Negative 2x equals negative 80. Divide by negative 2. X is 40 degrees. So my two angles are 25 degrees and 40 degrees. Now the next two questions are mixture problems, and we've already done mixture problems. And on your mixture problems we did substitution. Today I'm going to show you how to do an elimination with a mixture problem. Okay, Kevin has $15,000 to invest. His goal is to get 9% overall interest. He puts part of his money in one account that's 12% and part of the money in a 4% account. How much should go into each account to reach his goal? Okay, sentence 1. Kevin has $15,000 to invest, so he has a total $15,000. His goal is to get 9% overall. So his goal is 9% of 15,000. He has two accounts. There's a 12% account, which I'm going to call X, and there's a 4% account, which I'm going to call Y. Okay, so let's see what I got here. He has a total of 15,000 he's putting in two accounts, so X plus Y is going to equal 15,000. There are his two accounts. He has a 12% account and a 4% account, and his goal is to get 9% of 15,000. Now, if you don't like this way and you prefer to do the mixture problem, where we would have done 0.12x plus 0.04 times 15,000 minus x equals, let me change colors so you can see this on the blue, equals 9% of 15,000, you can do that. It's the same thing. This is just another way of doing it. So I'm going to get rid of the y's by multiplying by negative 0.04. So negative 0.04x minus 0.04y equals 0.04 times 15,000 is 600. And I have to get this too. 0.09 times 15,000 is 1350. Okay, so I get 0.08x, when I add those together, drops out, equals 750, because this is minus 750. It's minus because I had a negative here. Divide by 0.08. 750 divided by 0.08 is $9,375 is going into the X account, which was a 12% account. That leaves me 15,000 minus 93.75 for the other account, which gives me $5,625 going into the 4% account to reach my goal. So it's just another way of doing a mixture problem as an elimination rather than a substitution. But like I said, if you like substitution better, you're used to it, go ahead and use that. Coffee mixture is being made from a 12-pound bean and an 8-pound bean to make 50 pounds that costs $9. How much of each bean should be used? Well, there's two beans. There's a $12 a pound bean and there is an $8 a pound bean. And my goal is to get a $9 a pound bean for 50 pounds. So I have x plus y equals 50 pounds because the two of them together have to equal the 50 pounds. Then it's 12x plus 8y for the 12-pound bean and the 8-pound bean equals my goal of 9 times 50, which is 450. So I'm going to multiply the top one by negative 8. I'm going to get negative 8x minus 8y equals negative 400. Add 4x, drop, equals 50. Divide by 4. X is 12.5 pounds of the 12-pound beans. $12 per pound bean. So then 50 minus 12.5 is equal to y, which is 37.5 pounds of the $8 per pound bean. As a substitution, it would have been 12x plus 8 times 50 minus x equals 9 times 50. If you prefer it that way, I'm okay with that. Just showing you a second way of doing it now that we're into elimination. A Boeing 767 is flying from Washington, D.C. to San Francisco at a distance of 2,400 miles in 6 hours, and it's going against the wind. When you go against the wind, it's speed minus wind. Another Boeing 767 is flying from San Francisco to Washington, D.C. in 4 hours, and it's going with the wind. When you go with the wind, it's S plus W. What is the plane speed, and what is the airspeed, and what is the airspeed of the second plane? Okay, so we have two planes. My first plane, and we're doing distance, so D equals RT. My distance is 2,400. My time is 6 hours, and my speed is S minus W, or my rate. My second plane is going also 2,400 miles. It's doing it in 4 hours, and it's S plus W. So the first thing I'm going to do is distribute, so I can get them into standard form, because right now I cannot do anything with them. So 6s minus 6w equals 2,400. And 4s plus 4w equals 2,400. I'm going to multiply the top one by 2 and the bottom one by 3. That'll take my w's to 12 and negative 12. I'm going to move it down here. So 12s minus 12w equals 4,800. 12s plus 12w equals 7,200. Drops. 24s equals 4,800 plus 7,200, which is 12,000. Divide by 24. S is equal to 500 miles per hour. That is the speed of my plane. So 500 miles per hour is the plane speed. Now, I need to find out what the airspeed is and what the airspeed of the second plane is. So I need to put the 500 back in. So 6 times 500 minus 6w equals 2,400. 3,000 minus 6w equals 2,400. Move my 3,000. Negative 6w equals negative 600. Divide by negative 6. The wind speed is 100 miles per hour. Okay, so the wind speed is 1 mile, the airspeed is 100 miles per hour. I found my second thing. So here's my B answer. Here's my A answer. And now how fast is the second plane going? Well, the second plane is going with the wind, so it's 500 plus 100, which gives me 600 miles per hour. So the second plane is flying 600 miles per hour. So make sure you answer all the parts. So go back and reread the last sentences and make sure you answer all the parts. G of x equals negative 2x plus 11. F of x equals 3x plus 1. Where do they intersect? Well, remember, g of x is the same thing as saying y, and f of x is y. So I can either graph these or I can do equal value. I'm going to do equal value. Normally, if I have a choice, I do equal value just so that I don't have to waste the time and graph it and then find out it doesn't cross at a corner. So x is 2. I'm going to take that and plug that back in. 3 times 2 plus 1. 6 plus 1. Y is 7. So where's it cross? 2, 7. Okay, so that was our systems with 2. So what do we do when we have systems of 3? Well, people usually freak out when they have systems of 3, so I've come up with this little plan. What I do is I take equation 1 and 2 and put them together. So here's equation 1 and 2. I eliminate one of the letters, y. And then this becomes what I call my hold equation. I hold on to it for a second. Then I write down equation 2 and 3. I could write down 1 and 3, but I just do 2 and 3 to keep everything consistent. If you want to do 1 and 3, that's fine. I have to eliminate the exact same letter, so the y's have to go. I got it so that I multiplied the first equation by 2 to get the y's to go, and this is my second hold equation. I then take my hold equations and put them together, and I decide to eliminate one of the 2 variables that are left. In this case, I decided to get rid of x, so I multiplied everything by negative 3 the whole way across to get this. The x's go away. I get negative 11z equals negative 22, so z is 2. Now I take the 2 and plug it back in to one of my 2 hold equations. It makes no difference which one. I picked this one. So I have x plus 5 times 2 is 10 equals 13, so x is 3. Now I take my z and my x and I plug it back into one of these equations up here. I know that's a lot of lines. I picked the first one. So 5 plus y, I picked the first one. 3 plus y plus 2 equals 0. So that got to 5 plus y equals 0. So y must be negative 5. Therefore, my answer is x, y, and z in order 3, negative 5, 2. Okay, so we're going to try some. Okay, so I'm going to write down 1 and 2. And I put lines through my z's so I can recognize my sloppy writing. And I'm going to do 2 and 3. Now you can pick any letter you want to eliminate, but I like to eyeball it first. And I notice on the second one that the z's automatically drop out, so I'm getting rid of the z's. So these are going to drop out, and I add together, get x minus 2y equals negative 6. Then on this side, I'm going to have to multiply the top one by 2. 2x plus 2y plus 2z equals 6. 5x plus 3y, drop the z's, equal negative 17. I always like to have students with me just in case I go so fast that I make a mistake and think too fast. So hopefully they're correct. So x minus 2y equals negative 6, and 5x plus 3y equals negative 17. Multiply the top one by negative 5. Negative 5x, shouldn't have drew that line. Negative 5x plus 10y equals 30. Drops. 13y equals 13. Divide by 13. Y is 1. Now I'm going to take that 1 and plug it back into one of the two pink equations. They're my hold equations. I think I'm going to pick this one. It looks easier. X minus 2 times 1 equals negative 6. X minus 2 equals negative 6. Add 2. X is negative 4. Now I'm going to take the y and the 1 and x negative 4 and plug it back into one of these top equations. And I guarantee the first one looks the easiest. So negative 4 plus 1 plus z equals 3. Negative 3 plus z equals 3. Move my 3. Z is 6. Answer, negative 4, 1, 6. And you can plug them back into both of the equations to make sure that they work. I mean, all three of the equations, not both, all of them. Okay, let's go to one that has some holes in it. Okay, this one has holes in it. So what I do is I look at it and I look for two equations that have the same letters in them. So these two have the same letters in them. So I can take 2x plus 3y equals negative 4 and 16x plus 2y equals 1 and do it like a two equation system. I'm going to multiply the top one by negative 8. Negative 16x minus 24y equals 32. The 16x's drop out. I get negative 22y equals 33. Divide by negative 22. Y is equal to negative 3 over 2. So if y equals negative 3 over 2, I plug it back into one of my two equations here. 16x plus 2 times negative 3 over 2 equals 1. 2's drop out. 16x minus 3 equals 1. Add 3. 16x equals 4. Divide by 16. X is 1/4. So 1/4, negative 3/2. Now, I have x and y. If you go back, I only need z now. And to get z, I have to use the first equation. I know what x is. So 4 times 1/4 plus z is 4. 1 plus z is 4. Subtract 1. Z is 3. So 1/4, negative 3/2, 3. So it's a little, I think it's a little more difficult when there's holes in it just because you have to think differently. You can't always just take 1 and 2 and 2 and 3. So you have to look at the ones that have the same to start the equation off and get some of the answers and then go back in and fill in the blanks. Okay, one more. X minus 3y minus z is 4, 1. X minus 2y plus 2z is 5, 2. X minus 2y plus 2z is 5, 2. 2x minus 5y plus z is 9, 3. And then, like I said, you could have done 1 and 3. I just always do 1 and 2, 2 and 3 to keep things consistent. I think I'm going to get rid of the x's this time. I'll multiply this one by negative 1 and get negative x plus 3y plus z equals negative 4. X's drop out. Y plus 3z equals 1. Multiply the top one by negative 2, get negative 2x plus 4y minus 4z equals negative 10. Drops. Negative y minus 3z equals negative 1. Put them, another hold. Put them together. Y plus 3z equals 1, and negative y minus 3z equals negative 1. Gone, gone, gone. 0 equals 0. It's an identity, so it's all real numbers. And that can happen with 3's too. Just like you can have them parallel and they have no solution. Okay, so we just finished systems of equations. And now it's your turn to practice.